There's an update for VS Code. This is a project Pong LAN where you can play Pong over the LAN. And realistically, it doesn't have to just be LAN. You could do it over the real internet, but you're going to either need a server, you're going to need to do the routing. But I mean, if you know how to, you can give it an IP. It just takes an IP, the port's static. So we're going to just go ahead and run it. /Pong LAN. And we're going to, of course, do it again because this is a two-player game. So that's Pong LAN. We got this one, and we got this one. So this guy's going to host. So you're going to click on copy code. This was made with SFML. That was a graphics library because it's a very simple C++ graphics library. You click join over here. You got a IM player 1. And then you got a join request. So yeah. And then here you see player 2 popped up. So the host will start the game. This guy can leave. There's a bunch of different syncing issues. I never made this into a fully fledged, like all the buttons work, but it was more of the idea. I could get the buttons to work. I'm just not really that interested in it because I've effectively got the main point across if I think so. Did I do it well? We'll go into that. So really, you use WASD keys. I always forget that. So I need a better way of moving this here ball. I need a, excuse me, ball, not ball. I need a better way of giving the ball a speed and direction. And I don't remember if the ball speeds up whenever it bounces off a paddle, but I think it does. I believe it does. So it certainly gets more difficult. But if you see, if this guy misses, this dude's point goes up, this dude's point goes up. Same thing here. So you are always playing on the left side. So this guy would be playing on the left, this guy would be playing on the left. And the reason I say did I do it well is because a lot of times if the guest barely hits the paddle, like I don't think it hit there. But like if he barely hits it, like I think that hit right there. It's often delayed. So as you can see up here, we can just compare it. So you can very easily see that amount of lag. So syncing between the two games is something I've been trying to, that's something I actually want to fix. But like right there, that was pretty good. I don't know why. So I think it's an initial position. I think that's the problem. It's for some reason, and I'm trying to tell if once you let go, if it immediately snacks back or if it's still laggy. But I mean, for the most part, it does what it does. So this took me way too long comparatively to make because this thing's only about 1,000 lines long. But I have an actor class which is going to be just pretty much any object, the paddle or the ball. And then I have a button class which is for the main screens. And I have the main function which creates an instance of Pong Game, and then runs it. Paddle, it inherits from actor. This is the CPP, inherits from actor. Excuse me. So you can just have a list of actors in the Pong game, and you just call those actors update functions. So update right here. Here we got the Pong CPP. This is where things get very complicated because this is a lot longer than most of the other files. Pong HPP. So I have a lot of definitions for the metadata within the packets you're sending between the client and the host. So here I have where's the union? I have a union. This is what you're sending every single time, no matter what you're sending. If you're sending ball data, if you're sending paddle data, if you're sending request join, all of it. So here you got a ping, ball info, update. Don't remember what that is. This is for like just like miscellaneous things, except join, I guess. Then you got a join request, Yeah, character info. This would be like your paddle moving. So, and then within these, you have the type again, because that's how unions work. Character who it's from, and then the, I guess it's hit. I don't know. And then here's the ball velocity and the ball location, all of that good stuff.
All of that good stuff, Kermit.
So, I mean, but the something interesting that I wanted to take out of this is that the network part of this stuff is actually multi-threaded, and this is where I wish I made a network class, or at least a network file, even if I didn't make a class, because this stuff gets very messy. So here we've got the region network, and we got a bind socket. This binds the socket, and then you actually open the socket. So this binding is where you would, not where you choose, but this is where you choose. So what's the difference? This binds, and then this creates the socket. Okay, so you're actually not binding a socket here. You're more or less, you're claiming the IP in port. That's what this function does. In the kernel, you're telling the kernel, I want to use this. Kernel accepts or it doesn't. You got error handling right here. If it doesn't accept, it'll appear, it'll say why you can't use it. And then here it actually takes the socket. And I've written this for Windows and Linux, so you can compile to both, sort of. I don't know if you can compile natively on Windows. I cross-compiled for Windows. Here you get a new connection. Don't remember what this does. This is what comments are for. Once again, I've certainly gotten better at doing that. String stream code. So this will take a code, that code that I copied earlier, and we'll use that to turn into, change configuration. I don't think this is even ever called. I made this for the future. Yep, it's never even called. I was eventually going to use this if I made my game more of an actual working application and not more of just a demonstration. I was planning on making more of an application, but I wanted to move on to other things. I think I got my point across of like using C sockets to send data and also using a little bit of Engine graphics library stuff. So, and then here we have the guest network loop, which should actually be multi-threaded right here, std thread. And I used a bunch of, I wouldn't say a bunch of, but I used, what are they called? Dang, my mind is blanking. Let's come over to Pong. Let's see if we can find it. Mutexes. They begin with an M, I'm sure. Mutex. Mutex to make sure you're not writing over any data. So here's the guest network loop. So this will wait. When it receives something, it will handle it. Equals receive server. Okay, yeah, so I see what this does now. So this receive, it returns receive info union / struct. It is a union, but it's pretty much a struct. It's a union. It's a union. This received into calls receive from, which is a kernel level thing. So this blocks until the kernel will receive something on this socket ID. This is the memory location of it. This will be the size of it. This says it should wait for the message. This is what the destinate or the sender address is, and then this is the length of the sender address, and it will return RI received info, which is the actual data being sent, and then it will switch the type of the union, and then whatever it is, it will do a bunch of different stuff. If it has to write over data, am I using mutexes? Where are the mutexes? I don't see any. Break queue. I don't see any locks. I don't see any locks anywhere. I thought I was using mutexes. Maybe not. Well, that's dangerous. Use mutexes, kids. Host network loop. This will run for the host. This is a little bit different, so it sends different things. It also manages whether someone can join or not. That's what this does right here. This when someone joins the game, I don't know if this is the best way to do it, but this is how I am doing it. This will actually create the buttons. This will allow you to start the game, and this will show that player 2 is joined. And that player 2 thing pops up. It's just a button, but when you click it, it runs this function that does nothing. So I'm actually very proud of the way I've implemented buttons. I think that's good. Here I actually do use a mutex. Look at that. Look at that. So I am using a mutex. There's another mutex. Look at that. Look at that. That's just amazing. So, and then we have a queue loop. Is this double threaded? Is this using 2 threads? It is. It's using 2 threads. Okay. Well, it's using 3 threads in total for main, queue, and then, so the queue loop is actually a thread that waits. It will wait right here. What will it wait for? I don't know. B equals false. So this is a block. So block is false. Could use a better name for that. And then we're going to use a condition variable to wait. It will return B. So if this returns true, then it unblocks. If it doesn't, then yeah. So this here is a lambda function, passing it the class, so it has reference to B. And then depending on what you switch the front, send queue front. Okay, yeah. So the queue is this std queue, I believe. Yeah, std queue. Grabs the front and whatever the front is. Yeah, so it's just a list. It's simply just it's a queue of integers. Depending on the integer you pass to it, which are all defined as definitions, it will do different things. So if you want to send the ball, it will send the ball. It'll actually write it to send SI for send information, even though it's still a received info type. And then here it will send it. If you are 0, the host. If you are not 0, it will send it to the server. But if you are the host, it will send it to the client. And then it will get rid of that queue. And then it will go on to the next one. So I'm actually very proud of also the way I've multi-threaded these things. It wasn't as difficult. This uses the IP to code. Just this quick overview is no longer very quick. But that's okay, because you got the main idea, you got a demonstration. If you want to stay for more, you can. Region screens, I also am very happy the way this works. So the way the screens work, in my main function, I want to see if I have it written here. It's probably going to be up here in screens. Host lobby, guest lobby, intro code, main menu, game. Where's that main loop? Button handles. Main loop, here it is. All right, it should be here. So while running, this is just the main loop. It will return this class. So it's a function of this class. So here, let's go to a, that's the wrong file. Pong HPP, there we go. So here we have a void pointer, not a void pointer, but a pointer to a void function of the Pong class. This is the pointer, this is the name, this is this, and by default it is set to the main menu. Then this, it's actually, if you just look at this, it's actually really interesting the way it works. So you're pointing to this, so this is the type. So this class, you're going to dereference it, and then you're actually going to just dereference the pointer to the function, which is this, and then you're going to call the function. And this is how the screens work. So when you click on something, the pointer changes. And I actually really like how this works. What are you mad about? I expected a member name. Yeah, blah, 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 whatever. So, and then here you have the screens up here. So, host lobby. If you were to click on, excuse me. Let's go to main menu. So main menu, it adds a host game, and the function it runs. Oh, that's right. Excuse me. Need a sneeze? Excuse me. Excuse you. Here is actually the button functions, and I made this one function eventually, so you can just have these together. So when you click on a button, it will run the button's function of I. So a lot of pointers to functions. Pointers to member functions, which is honestly fairly difficult if you don't know how to use pointers properly. And I will admit, I always have to look up how to do this because I always forget how to do this because the syntax is strange. But it is what it is. So I'm going to stop it here. This video's been long enough. If I want to make more, I will. If I don't, oh well.